Solving circuits. When it comes to solving circuits, Jimmy, there's actually two laws. They were formulated by, I believe, a Russian physicist. His last name was Kirchhoff or Kirchhoff, or anyways. There's a voltage law and there's a current law. And if you wrap your brain around those, believe it or not, I could probably even give you some of my university physics circuitry problems, and you can probably handle them. They just get uglier. I can't say they get much tougher. They just get, I got to keep track of a lot more stuff uglier. So we have two laws. Here is the current law. It says this. First of all, current in a circuit flows downhill. Current flows, you okay, Nick? You good? You with me? Mansion, you good? Okay, looks like you're kind of out of it or something like that. Current flows from the positive terminal, remember my abbreviation for positive is plus VE, of a voltage source. This year for you it's going to be batteries most of the time. Through the circuit to the what terminal? Negative. Electrons flow from negative to positive, but we've defined current as flowing from positive to negative because it makes the math much nicer. Welcome back, by the way. We missed you. So, first rule of current is you always ski downhill from positive to negative, from a higher voltage to a lower voltage, from a higher height to a lower height. This is why I use a ski hill as my analogy. The second rule is this. At any junction, any place where wires connect or split up, the current flowing in has to equal the current flowing out. My analogy for current is skiers. And we're not going to have skiers be allowed to vanish. Our ski hill is not going to have any missing people or fatalities or anything like that. Current cannot vanish. It can split up and recombine. So in terms of my ski hill analogy, the current law simply means that if three skiers converge on an intersection, if I have one skier here and two skiers here, how many skiers have to flow out? 3. If I have 2 amps coming in and 1 amp coming in, how many amps am I going to get out? 3. Okay? So example 1 says, find the unknown currents. We're going to start off a little simple, hopefully, and we're going to get more complicated. First thing I always do before I do anything else, whenever I'm analyzing a circuit, I find the battery. That's that guy. Don't circle it yourself. Which way is positive? Going up or going down? That's the direction of the current, and this I'm going to encourage you to do because it takes 1 second. I always draw arrows saying that's downhill, that's downhill, that's downhill. I do that. Do that. Because that tells me which way I'm going to move my eyes as I analyze this circuit, Mara. Mara, how many amps right there? Read it to me, please, kiddo.
1.75.
How many amps right here? Same answer.
1.7.
How many amps right here? Same answer.
1.7.
How many amps right here? Same answer.
1.7.
How many amps are leaving the battery? Same answer.
1.7.
So 1.75 amps, 1.75 amps, 1.75 amps, 1.75 amps, 1.75 amps. How many amps right there?
1. Oh, 1.7.
Yep. 1.75. How many amps right here?
1.75.
Yep. And the reason that's the case is there are no junctions in that circuit. There's no wires that split up and rejoin. As opposed to, you can see in the next picture, there's some splitting up and rejoining. Okay? Current doesn't vanish. Allie, you want to go skiing with me? Can I take you skiing? Let's go skiing. First thing I'm going to do is label downhill. I see the battery. That's downhill. That's downhill. Now, right here, Allie, it looks like downhill is that way and that way. Right? Downhill, 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 downhill. And that gets us to the bottom of the chairlift of the battery. You okay with that? Now, I've already then taken care of the direction question. Right here it says direction. Which way is the current flowing? Which way is my arrow pointing? To the left or to the right? So let's all circle that. Yes? Which way is the current flowing here? Because that's downhill. Which way are the electrons flowing? In the opposite direction, but we've already decided Ben Franklin named positive and negative wrong. It really would be much, much nicer to think of things as positives moving through a circuit. Okay. Allie, how many amps right here?
3.
So how many amps leaving the battery? Same answer. Because there's no junctions, there's nowhere else for them to go. That means this current has a total this circuit has a total current of 3 amps. How many amps? Right here we split up. How many amps went this way? Read it to me.
0.8 amps.
So how many amps went this way?
2.3.
Yes. Did you hear him? This is the current rule. Current splits up and rejoins. Let's follow that outer loop. So let's keep going, keep going, keep going. How many amps are going through this resistor? I didn't ask you. 2.2 amps. That resistor, whatever appliance it is, I'm telling you, if you hooked up an ammeter to it, you would measure 2.2 amps. What's the current right at the bottom here?
2.2.
Ah, good. Now we meet up again. How many amps are right here? 3. So how many amps right here? 3. That is the rule for current. It splits up and rejoins. In fact, you're going to hear me say mentioned, once we get into really complicated stuff, if I can find the total current leaving the battery, the question's going to fall apart. And that's what my strategy, once I have more tools at my disposal, Sarah, if you're asking me, how do I approach these? I always try and find total current. Because if I can, the question's going to fall apart. Example 2 says, show the direction of each current and find the unknown currents. Julia, you want to go skiing with me? Can I take you skiing?
Yeah.
Okay. First thing I'm going to do before I start, label which way is downhill. So that's downhill. Downhill. Right here we split up. I guess, Julia, that's downhill and that's downhill. Let's follow the top line still. It splits up one more time right there. I guess that's downhill, that's downhill. Downhill is to the left on the bottom there. Yeah? And still to the left on the bottom there. And still to the left on the bottom here. And then that's what gets us to the bottom of the chairlift. By the way, this ski hill has 3 ski runs. Some skiers can follow that path. Some skiers can follow that path. And some skiers can follow that path. All of those will get you always going downhill and to the bottom. Okay. How many amps are leaving the chairlift? Do I know? Yes, I do, but not yet. So how many amps do I know right now, this moment? I don't know. Ski with me. How many amps went that way? How many amps went this way? How many amps must be right there so that I can split up and get 8 that way and 5 that way? 13. How many amps right here, Halia? How many amps right here, Halia? How many amps are leaving the battery? Yes. And that's the total current in this circuit. Cleo, did I just figure out the total current? This question's going to fall apart. So sometimes I'll give it to you blatantly, and sometimes you have to do a bit of math to figure it out. Okay. Let's keep going along the top here. How many amps right here, Halia? How many amps went this way? So how many amps must have gone this way? How many amps right here?
5.
How many went this way?
2, 3.
Yes! Right? Let's follow this path. How many amps right here?
3.
Yep. And it looks like we rejoin. 5. Looks like we rejoin. So, yep. Okay. Current splits up and rejoins. In our ski hill analogy, you can't lose skiers. Now, our ski hill analogy breaks down if I use decimals, because like on one of the, what's 0.8 of a skier? You know, we're not going to go, but in terms of current, it still works for the math. Okay. Jordan, I want to go skiing. Can I take you skiing? Okay. Where's the battery? Okay. Which way is downhill from the battery? To the left or to the right? In this case, downhill, downhill, down. Looks like here we split up 3 ways. So I guess this is like coming to a fork, but there's 3 forks in the road. Some skiers can go to the left, some skiers stay in the middle, some skiers are going to go to the right. So that's downhill, That's downhill, downhill, and then we meet up again. Downhill, downhill. Looks like we split up right here, so downhill, downhill. Is that okay? Jordana, do I know the total skiers leaving the battery? The total current? I do? What? How'd you figure that out? Ah, see, I first looked here and I said, yeah, I'm missing one, so I can't figure it out. But I noticed that all the skiers rejoined here. And so if there's 5 amps right there, and that is all the skiers, there must be 5 amps leaving the battery. Good. That's the total current. This question's going to fall apart. How many amps right here?
2.5.
Oh, because I had 0.5 and 2, and I have 5 coming in. I have to have 5 going out. I must have 2.5 amps going that way. Now, in your lesson, by the way, I was able to make most of these work out so that you can do them in your head. The reason I'm saying get a calculator, Jimmy, in your homework, I didn't try and make them work out evenly. It's too much of a pain. Okay, let's keep skiing, keep skiing, keep skiing. How many amps right here? Gotta be. Because 2 amps forked off, and we had 5 amps coming in. In fact, what I sort of imagined to myself, Marco, is this. Right when the skiers, when the current got to here, they all shook hands and they split up. Some went this way, some went this way, some went that way. Now, you may be wondering, Mr. Dewick, why would they split up differently? The resistor is what changes that. All 3 of these have different resistances. It'll be 3 different light bulbs that demand 3 different currents, if you really want. And we're going to get there in a second, but if you really want to know why. Brianna, want to go skiing with me? You sure?
Mm-hmm.
Cleo, you want to go skiing with me?
Sure.
Let's go skiing. Okay. Where's the battery? Is downhill upwards or downwards in my picture? That way?
Yeah.
Which way is...
Yeah.
So, and I always remember that. I just start with the bigger one, okay?
Yeah.
And by the way, what I'm imagining the battery acting as is the chairlift. And on any ski run, your goal is to leave the top of the chairlift and then arrive back at the bottom of the chairlift. And that's why we're going in this direction as well. It's a good analogy. So downhill is this way,
Yeah.
that way. When we split up, downhill is going to be that way and then to the right. That way. Yeah. Following it, following it, following it, following it. That way. And then I guess in the bottom, downhill is to the left. And then over here, downhill is upwards on my piece of paper for a little bit. Okay. Do I know how many amps are leaving the battery?
No.
How many amps right here?
4.5.
How many amps right here?
Oh, 4.5.
How many amps right here?
4.5.
Do I know how many amps are leaving the battery? I do. They just moved it further down. In other words, do I know total current? Say yes. This question is going to fall apart. So here we go. How many amps right here?
4.5.
So how many amps right before we get to the junction? Still.
4.5.
And they split up. How many amps went this way?
1.
How many amps must have gone this way?
3.5.
Yep. He was going to do the math in his head, though. Let's continue on that path on the outside. So how many amps right here? You just told me.
3.5.
How many amps right here?
3.5.
Gotta be. How many amps right here?
3.5.
Oh, here's a junction. Let's go back to where we split up originally. Let's go this way. How many amps right there?
1.
How many amps right there?
1.
Mm-hmm. Yes. And now we meet up. How many amps right here?
4.5.
Yes. That's the current rule. Now let's do the voltage rule. Voltage rule is a tiny bit trickier, but not too bad still. Oh yeah, turn the page. So current splits up and rejoins, and you have to kind of memorize that, but I'll give you enough practice, Mara, that you will memorize that, okay? The voltage law says this: if we walk, or if you want to, you can cross out the word walk and put the word ski, it's up to you. If we ski around a circuit, always going downhill, any voltage gained has to equal voltage lost. Brooklyn, in terms of my ski hill analogy, what that means is if the chairlift is 10 volts high, to get to the ground, you have to lose 10 volts. Otherwise, you can't get to the bottom of the chairlift. If the chairlift is 50 volts high, how many volts do I have to lose going through the circuit? If the chairlift is a 65 volt battery, I have to lose 60 volts going through the circuit. Okay? So, voltage law simply says that the chairlift takes you to the top of the mountain. From there, as you ski down the mountain along any path, the total drops have to equal the battery. There's my ski hill analogy. So, ready? Here we go. I'm going to zoom in on this picture here. Jimmy, you want to go skiing with me?
No thanks.
You're going to go skiing anyways.
Okay.
Ready, Jimmy? How big is the battery?
20 volts.
In other words, how much height do I have to, how much voltage, how much height do I have to deal with? 20 volts. That means I have to lose 20 volts going through here. Otherwise, it's an impossible circuit. So right now, I'm still at 20 volts. Now, where do we lose height? Resistors. They bleed off voltage. We're going to have our wires be perfect. In real life, you do lose a tiny, tiny bit of voltage going through the wires themselves, but that makes the math yucky, and most electricians ignore that. What you do if you become an electrician is you always make sure use a minimum amount of wire, because you do lose in real life some to the wires. We're in our magic physics world where all the math works out nice. How many volts right now?
20.
How many volts right here? Still 20.
Yep.
But this first resistor, I lose 8 volts.
So then you have 12.
Yep. This next resistor, I don't know, but how many volts right here?
So,
Here, read it to me.
oh, 0 there.
How many volts right here then?
0.
How many volts must I have lost going through this resistor if I started out 12 high and ended up 0 high? We don't put a minus. We assume since it's a resistor, you know we're talking about a loss. We're lazy. So we'll actually call it a drop. And you'll hear me as we get good at this. I'll just say, what's our voltage drop? 12. You don't have to say negative. I know you mean it. That's the voltage law. Let's get a little more complicated. Amy, can I take you skiing? Okay. Battery, see it? You know what I didn't do last time and I should have with Jimmy? Although it was a simpler circuit, this one's more complicated. Let's label downhill. Downhill, 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 downhill. This is what's going to tell me which way my eyes are going to move. Now we're looking at voltage. How high is this chairlift? How high is this battery? 10 volts. So starting out 0 volts high, the charges travel through this battery, and that's really what a chemical battery does, is it raises the energy level of the charges. It gives them some energy to bleed off. How many volts would I read right here still? Good. Now, we can go through 2 hills. We can go down this hill or that hill. Let's go down the middle hill. Okay? Before we hit the hill, how high are we still? Whee! We go down the hill. I don't know how big that hill is, except how high did I end up? So how many volts must I have lost going through that hill? Has to. And that's what would get me to 0 volts there. In other words, if you took a voltmeter and you put one end above the resistor and one wire below the resistor, it would measure negative 10 volts. It would measure a 10 volt drop going through there. We played around with the voltmeters. We set them up to measure positive voltages because we were trying to build batteries, but this is where you were losing voltage. Let's go on the other ski hill. How high are we right here? How high are we still right here? Because we haven't gone down any hills yet. Whee! And then I get down to here. How many volts must I lose going through that? Yeah. Because that's what gets me down to the ground. You're also starting to see a little bit where some of our terminology like ground and things come from in circuitry. Is that okay? Thank you for skiing with me. Let's take it up a notch. Nick, you want to go skiing with me? Okay. You're going to go skiing with me. Where's the battery? Yeah. All the way over on the left. Let's label downhill, which is going to be that way, that way, that way, that way, that way, that way. You okay with how we're getting the downhill thing, folks? I'm just moving my eyes, but I'm making sure I keep going in the same direction as the wrong word, in the same flow. Is that okay? How big is this battery? It's a 12-volt battery. It's a car battery, if you want to know where we're picking some numbers from. So right here, if I put a voltmeter right there and right there, what would I read right here, Nick? Good. Now, this first resistor, I lose 8 volts. So how many volts are left right here? Yep. Whee! We go down this ski hill. How many volts high am I now? Well, apparently that gets me to the bottom. So if this is 0 volts, how many volts must I lose going through that resistor? Yep. Let's do the right-hand hill. You lose 4 to get to 0. Put your pencil down, look up. So here's the first thing that's a bit weird. If I look at the resistors, I'm just going to circle them. Right there, right there, right there. How many volts in total have I lost? Add them up. How many volts is my battery? Don't think that your total voltage and your battery will match. They won't. But on any ski run, I can go down this ski run and I've lost 12 volts. Or I can go down this ski run and I've lost 12 volts. That will always work. But don't think that for voltage you can just add up all the voltages willy-nilly and say, oh, equal the battery. In fact, you'll have some circuits where your battery is like 12 volts, but if you, I've got like 40 volts of loss going through my circuit, it's because the current is splitting up. Mansion, you want to go skiing with me? It's really a rhetorical question. Come back to you in a bit. Where's the battery? Yeah, 60 volts. This is 5 car batteries wired together. Downhill is up on the left, to the right along the top, down, and then along the bottom to the left. Clea, you got a question or not? Okay. Or are you trying to work ahead and figure things out? Yeah. This is like addictive candy to me. We're almost there. Okay, Mansion, what goes in this blank right here? I agree with you. That's our voltage source. What do we lose going through this resistor? Leaving how much? So right here, we got 45 volts left to play with. Let's go down the middle run. Whee! How many volts are left right here? Do that in your head or with a calculator? All right, nice job. How many volts incoming still? 27? How many volts must I lose through this bottom resistor then? Have to, otherwise I can't get to 0. Let's go do the outer run. Now, if you are in our ski hill analogy, I guess right here, Manchand, our group decided to split up. Some of you went down one big hill. Some of you went down 2 smaller hills. The first hill, we lose 18 volts, leaving how much? 35. Sorry, did I say 18? We lose 10 volts. Did I say 18? The first hill, we lose 10 volts, leaving 35. How big must this hill be? No, right there is 35. How big must... Sorry? Got to be 8. In fact, you'll notice really, Halia, the big hill was 18 volts and the 2 smaller hills had to add to 18 volts because otherwise, how could we split up and meet up if we didn't all go through the same height? Otherwise, that's impossible. Okay. Now, right now, we've been writing voltages all over the place. Too much work. Too much work. So I wrote down here, it's helpful at first to label the voltages everywhere. What we're going to do now, Marco, instead, is we're only going to label the resistors, because that's where all the action is happening. We're going to put it all together. Marco, you ready to go skiing with me? Okay. I like example 8, I like example 8, I like example 8. Example 8 is a nice question. It says this: find the unknown voltage drops, currents, and resistances. Do me a favor. We're going to put a little comma here. And power. I can actually tell you how many watts. Let's assume these are all light bulbs. I can tell you how many watts each of these bulbs is going to be. Marco, where's the battery? On the left? So let's label downhill. So far, so good. Start with current. In fact, if we can find total current, this question's going to fall apart. So we start with the current, then we deal with the voltage. And what you're going to hear me say is this: find any resistor where you know two things. Because if you know two things, you know four things. Is there a resistor where I know two pieces of information? Right there. Okay? So, V equals I times R. What's the equation for R from your yellow formula sheet, please? So I can already tell you the resistance of this bulb. What's R for this bulb? It's going to be 6 divided by 4, which is 1.5, I think? Yes?
Yeah.
How many watts is this bulb? Power, what's the equation for power? No. V times I, that's the one we're going to use. I can do that in my head. V, 6, I, 4. This is a 24 watt bulb. Yes, has to be. So, Jordana, one of the things you're going to hear me say is if I know two things, I know four things. If I know two things, I know four things. All right, let's ski. How many amps right here? How many amps went this way? How many amps must have gone this way then? Yes? Oh, and I can tell you 4 amps at the bottom entering the battery again. Yes? Right there. You okay with that? Okay. Do I know two things anywhere yet? Do I know two things here? Say no. Do I know two things here? Because as soon as I know two, I stop and I find whatever else I can. Okay, now we have to go skiing with voltage. So we did our current trick. Now let's do the voltage trick. How many volts am I starting with? What do I lose going through here? Leaving. How much? 12? Yes? Right? Start with 18. You lose 6 going through here, leaving 12. So now let's go down the middle hill. How many volts must I lose in this middle hill if that gets me down to the bottom? Has to be. Do I know two things? Stop. Then I know four things. I can find R and I can find P. Use the formulas from your sheet. It's V over I. Oh, I can do that in my head. 12 divided by 3. Is R 4 ohms? Double check me, but I think so.
Yep.
Yes? 4 ohms. And power is V times I. I can do that in my head. Is it a 36 watt bulb? Or am I wrong? 36, yeah? No?
Yeah.
I think it's 4 or 6 volts?
Yeah, so you lose 12.
No. I lose 6. 6 volts. I'm right. It's 30. It's a 36 watt bulb. Yes? No? Yeah. 12 times 3.
Oh.
V times I, people. Keep your letters straight.
R.
Okay? Marco, back to you. Let's analyze this. Start at the battery again. How many volts? Lose. Leaving. How many volts must I lose here? So, how many volts do I lose here? Leaving how much? Say it. So how many volts must I lose if that gets me down to the ground? It's also got to be, no, it's got to be 12. Because, look, on this run, that should add to 18 volts. Does it? 6 and 12. Okay, this is how the voltage law works. The voltage law is the trickiest one. But, Marco, do I know 2 things? Say yes. Then I know 4 things. I can tell you the resistance. It's going to be V over I, which is, I can do in my head, 12 ohms. And I know the power, which is going to be V times I, which I can also do in my head, 12 times 1, 12 watts. So I'll tell you a neat test question would be to give you this circuit, and instead of saying solve the circuit, I would simply say, which bulb is the brightest? Which of these is the brightest bulb? My mom says I'm not the brightest bulb. Jamie, she means something different. Which of these is the brightest bulb? You knew that was coming. Come on. You had to know that was coming. Which of these is the brightest bulb? First one, top one, middle one, or right one?
Or the middle one.
Middle one, 36 watts. It'd be the brightest bulb. It'd be giving off the most light. Okay. So we're going to be using these and all the different variations and our 2 rules, and we can now solve any circuit on the planet. Sorry, it really didn't get much tougher than this. Turn the page. Sarah, you want to go skiing with me? It's a rhetorical question. You're going skiing with me. Where's the battery? Over on the? Okay. Downhill is that way, that way, that way, that way, that way, and that way. Is there anywhere I know 2 things? Do I know 2 things there? Say no. Do I know 2 things there? Do I know 2 things there?
No.
Okay. Always check that. Then I'm going to try and see if I can figure out total current. Do I know the total current leaving the battery? I do.
Oh, current,
No,
no.
not
You
current,
voltage.
sorry, not
I do. I do. What's the total current leaving the battery?
current. There's no.
Ready? How many amps went this way? How many amps went this way? So how many amps must have been right here? How many amps right here? How many amps right here? How many amps right here? Do I know the total current leaving the battery? If I'm clever and put Kirchhoff's laws together, the circuitry rule, yes. So I'm even going to label that, even though they didn't ask for it, I'm going to say 2.5 amps. Why? Do I know total current? Say yes.
Yes.
Question's going to fall apart. So you ready? Ski with me. How many amps going through this resistor? Let's write that down. Do I know 2 things? I know 4 things. What's R and what's P? R is going to be V divided by 21 divided by 2.5. Maybe I can do that in my head. It's going to be 21 divided by 4, which is... What do you get? 8.4? Even? Ohms. Oh yeah, dividing by 2.5, you times by 4 and divide by 10. I should have done that in my head. Tricks without a calculator. You learn them growing up. Power is V times I. That I can do in my head. It's going to be 21 plus 21 is 42 plus 10.5, 42, 52, 52.5?
Yeah.
Power is measured in watt? Watts. By the way, put the units next to everything. Otherwise, you will mix up your equations and your formulas. Some of you that were earlier going 12 times 4 or whatever, put the units on there. It helps you keep straight what goes with what. Sarah, let's keep skiing. So, how many amps right here? Oh, you know what? I've got my currents on either side, but I would use my current rule next. If, in other words, I really now don't need to know that. Now that I have the 2.5, I can figure that one out okay. Now we're going to do the voltages. Sarah, there are 2 ski runs. That one and this one. Do you want to do the outside one or the inside one? Pick. Outside? Okay. So we're going to start at the battery. How high? How many volts? Ski with me. How many volts do I lose here? 21. Leaving how much? So I got 14 volts. I've got to get rid of that. Ski with me, 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 ski with me. Whee! Ski with me, ski with me, ski with me, ski with me, ski with me. If I only went down one hill, how many volts does that hill have to lose? Has to. Stop. Do I know two things? I know four things. R is going to be 14 divided by 1.5. That's going to be 14 divided by 1.5 is the same as 3 over 2. So it's going to be 28 divided by 3. So it's going to be 9.333333333. Power is going to be V times I. Oh, 21? No? Yes?
Oh, yeah.
21? Well, we did the outer ski hill. I guess now we're going to do this ski hill. How high? We lose 21, leaving. Whee! And, oh, how many volts must I lose going through there? I have to. Do I know two things? I know four things. I can tell you R, and I can tell you P. Oh, this is easy. R is 14 ohms. And power is 14 watts.
What are you talking about, Mr. Duke?
Hey, which bulb is the brightest? The first one, the second one, or the third one, if we're moving from the left? Which is the brightest light bulb?
Third.
First one.
Whichever one has the highest wattage, right? 52.5. That's a brighter bulb. I'm assuming you guys have changed enough light bulbs to know higher wattage bulbs are brighter. Right? Or if it wasn't light bulbs, I would say, which of these appliances is using the most power? This one. Okay. Never changed a light bulb? Wow, you've been spoiled. Okay. All I can do is add more pathways and more ski runs, but it's going to be the same rules. It's going to be the same rules. C. Paige, ready to go skiing? Let's go skiing. Find the battery, see it on the left, 40 watts, 40 volts. I labeled downhill. Downhill, 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 downhill. Alrighty. Can I figure out total current? First of all, Sarah, this is really what we should have done. I should have said, did they give me total current leaving the battery, obviously, without even thinking about it? No. Sometimes they will, but no. Can I figure out the total current? I don't, because that would be the total current if they told me the current there. I know 1 amp went this way. Do I know how many amps went this way? So can I figure out total current? Say no. That's the first thing I check. And we're going to write this out systematically in a little while, a checklist. But first thing I look for, actually, first thing I do is label downhill. Second thing is, can I find total current? No. Third thing I look for is there anywhere where they told me two things? I'm starting there. Okay. If I know two things, I know three things. So I know four things. I can tell you R equals 35 ohms, and I can tell you P equals 35 times 1, right? I can do that in my head. Okay. Next thing, I ski. Okay. And I'm going to ski. There's two runs. Can you see there's this one and there's this one? I'll ski the one where I already know something. That one. I'm going to ski this middle run. So you ready? Here we go. Paige, how many volts am I starting with? Okay. How many volts do I lose here? I don't know. Whee! How many volts do I lose in this hill? Sorry? No, read it to me. 35. Does that get me all the way to the bottom? How many volts must I have lost in that first hill? 5. Has to be. Okay. Do I know two things? Say no. All right, let's start over. Let's ski the other run. You ready? How high am I starting with? Whee! How many volts should I just lose? Leaving. How many volts must I lose in that hill? I have to. And again, Sarah, going back to the question I asked you earlier, I know that means that you have 75 volts coming from a 40-volt battery. Voltage does not work that way. Each pathway is 40 volts. Pardon me? Always start at the battery and do a ski run. That's the rule that you can use. Oh, do I know two things? Then I know three things. What's the current? How many amps going through here? Now, let's see. I know voltage. I know resistance. Hey, is there an equation that has an I and a V and an R in it that has the I by itself? Can you read me that one page? V over R. So it's going to be 35 divided by 5. Now, if you want to write these steps out, Amy, you can. But I will allow you just to put the number here and say, hey, I know that that is 7 amps. I will assume you didn't cheat because I'm going to give you the answers to these. If you're dumb, you can just copy the answers and cheat, I guess. But I will not make you show me the formula and what you wrote out because I want you to get good enough that you can do these with a calculator almost in your head. So I will trust you on that. Are we done? Oh, power. V times I. 35 times 7. 245? Yeah. Probably not a light bulb. This is probably an appliance because a 245 watt bulb, maybe a heating lamp. I don't know how much wattage those pull out, but 245.
Yeah.
Paige, are we done? Say no. Oh. How many amps right there? How'd you figure that out? Because now I know I got 1 going that way and 7 going that way. I must have had 8 coming in. Do you see what I mean? That these are kind of little brain teaser puzzles, almost like little Sudoku or whatever. What's R? It's going to be 8. No, it's going to be 5 divided by 8, which is, I think, 0.625. Double check me. What's, yes? 0.625 ohms, and power is going to be V times I. Double check me, 40 watts, but I think so, yes? And this circuit is solved. You get through the whole thing? I don't know if we're going to get through the whole thing or not, Mr. Dewick. Let's see. I'm going to... You're going to be getting a massive package of homework, but we're going to spend several days on this. But you should draw on these and mark these up. This is one of the reasons I type up my notes. Circuits, to try and do them from a textbook, if you can't mark up the circuit, it's a pain. And if you have to copy out the circuit, the odds of you copying it down wrong are pretty high. That's a pain too. So we're going to press pause for a second here.